Lesson 3.4 has an extension on it. It's 3.4 inequalities is what I'm going to call it. The objectives are to solve exponential inequalities algebraically and solve logarithmic inequalities algebraically. So in lesson 3.4 we solved equations. Now we're going to solve inequalities. Before we begin that, I thought I saw this on an internet, and I thought, well, I might share this with you. And it says, what quantity is represented by this diagram? So quantity, what number is represented by this? I'll give you a little time to think about it. But here's a response that was given. I thought it was quite clever. The answer was 9. Why was it 9? Well, it was 9 because it was tree plus tree plus tree. Get it? Tree. Anyway. Another question that they asked on the same diagram. How about a dust storm blows through? Now how much do you have? So here comes a big dust storm, blows over a diagram. What quantity is now represented by this? And this one's quite clever as well. 99. Dirty tree plus dirty tree. 99. Final one. Hope you have a sense of humor. Some birds go flying by and leave their droppings, one per tree. How many is that? So what quantity would this be? And that one we will share later. I'm not going to give you the answer to that one at this point, but we'll share that later. Think about what the answers have been so far, and then we'll see if we can come up with a nice numerical answer for that representation. So, carrying on. What we're going to look at first is how to solve an exponential inequality algebraically. What we're going to do is we're going to use the same skills that we used the other day, and then we're going to use a little interpretation on how do we do these with inequalities. So first one set up here we have, and these are the exact same examples that they have in the textbook. I just copied those. They didn't give me any others to go by. So I'm just going to talk through the ones that they have in the textbook as far as lining up with them right away. So in order to solve an exponential equation, we want to undo the exponents, and that would be to use your logarithms. The other thing that we could try to do is we could try to look at this and see if there's a common base between 5 and 0.04. And if we convert that 0.04, it might make it a little bit easier to recognize the common base, which I think is in there. We just have to go find it. So I got to orient the board for a moment. Okay, back in action here. So there's 4 hundredths. If I think of writing that differently, that's 4 over 100, which could be reduced down to 1 over 25, and that makes it a little bit easier to recognize the common base between the 5 raised to 2x minus 6. It's got to be greater than, and now I'm going to convert and just use a different representation of 400, so I'm going to use 1 over 25 raised to the power of x minus 3. Now I want to get a common base, so this 5 and this 25 have a very commonality here. It's the base of 5, so it's 2x minus 6. And greater than this 1 over 25. First thing I want to do is I want to flip it. I want to make it a 25 over 1. In order to do that, I have to put a negative exponent. So it's got to be negative, and then x minus 3. The second thing I have to do is represent 25 as 5 squared. So it's 5 squared to the negative x minus 3, which means I can pull the 2 out, and it's going to be 5 raised to the negative 2 times x minus 3. And now I'm going to take all that information and put it over here. It's 5 raised to the negative 2 times x minus 3. Now I have a common base of 5 underneath of them, on both of them. So this 2x minus 6 has to be greater than a negative 2 times x minus 3. And then we're going to solve the resulting linear equation. So 2x minus 6 has to be greater than a negative 2x plus 6. So getting the x's on the same side, we've got 4x has to be greater than, getting the 6 on the other side, you have to add it, gives us a 12, which means x has to be greater than 3. So algebraically, what this is telling us, as long as we have a value of x that is greater than 3, we'll find a solution that will solve the initial inequality. You can always back these things up, and in the textbook they're going to show you the graphical solution as well. I'm going to emphasize the algebraic solution, and you can reinforce this by going back and checking it graphically if you'd like. But we have found that value of x, which will make that determination. So not a lot of changes here. All we're doing is we're going to interpret our inequality and make sure that we have that. So should be done with that part of our lesson.